YouTube channel. In this lecture, we are going to discuss the recursion. Recursion is nothing but a method calling itself again and again to perform a same operation is known as an recursion. We will see the example. Here, I created a method add public static void add of system.out.println add begin. Here, add is a method. So again I am calling the method to perform a same operation. Again I am calling the same method. It means the output would be first class p1 public static void main string arguments, next system.out.println main begins. First output would be main begins. After that add means it will go to the add method. Next system.out.println add begins. Next it will give add begins. After that next statement add, so again it will go to the add method, so again it will leads to the add begin. Next again this loop continues, so it leads to the exception. So to overcome this exception we will use base case condition. See here, I hope you understand what is recursion, right? A method calling itself again and again to perform a same operation is known as an recursion. If the recursion occurs in a program not handled efficiently, as we seen it repeatedly takes place, the below statement is not executed, right? So it not handled efficiency. So to overcome this problem we have base case condition, and here we get stack overflow exception. When we calling the again and again in the same operation, then we will get stack overflow exception because it not handled efficiently. So by using the base case condition we can overcome this problem. See, we can avoid or stop the recursion by using the base case condition. Here we have direct recursion and indirect recursion. A method calling itself again and again is known as an direct recursion. It means a method which calling by itself is known as a direct recursion. See, this is the example for the direct recursion, which is an add method. A method which is calling by itself again and again is known as an direct recursion. Next, indirect recursion. A method calling each other is known as an indirect recursion. For example, there is an add method and there is a subtraction method. Here this method calling takes place here, add method calling takes place here, but repeatedly it happens again and again. It leads to the indirect recursion. We will see the example in the next slide. See, here I divided into the two partitions to understand easily. See, class P1 public static void main string arguments, I call the add method, so it will go to the add. Here I have system.out.println ab. In the next statement sub, so again it will go to the sub. Next system.out.println s. Next statement would be calling the add method. Next it would be calling the sub method. So repeatedly the method calling statements takes place. A method calling again and again between each other is known as an indirect recursion. Here it's not handled efficiently by using these recursions, right? So to overcome this problem we have seen base case condition. So let's see the example for the base case condition. By using the base case condition we have if and else. By using the if and else we can achieve the base case condition. Recursion is nothing but a method calling itself again and again to perform a same operation is known as an recursion. But by doing it so, it leads to the stack overflow exception. So that means it doesn't stop somewhere, but by using the if and else we are able to stop some condition. We have to stop that program at some condition. So at that condition we will write in the if block. If the condition is false, then it comes out of the block. So we can achieve this recursion without leads to the stack overflow exception. That means if I had to print the 1 to 5 numbers, if I write if n is less than 5, I will print 1 2 3 4 5. If I get 6, the statement becomes false, so it comes out of the block. See here, the same we will apply in the program. Class P1, static int sum is equals to 0. Public static void main string arguments add of 1. Add is a method. Oh, just a minute. Add is a method. I am passing the arguments, actual arguments, with the 1 to the formal arguments. Here add of int n 1. Here system.out.println n. So the output would be first 1, next n plus plus. So the value becomes 2. It checks the condition 2 less than 5, right? So here we have, then we will return to the add method. So if the condition is true, it will enter to the block. So add n, that means what is the value of n? 2, right? 2. Then the value passes to the 2. Now n will become 2. Then I have to print system.out.println 2. So 2. Next the value will be incremented. It will become 3. 3 less than 5. It is true. So it will enter into the block. Add of 3. It means it is a method calling statement. It is a recursion. Then the value of n will become 3. Next system.out.println n. So 3. Next the value will be incremented. So 3 will become 4. 4 is less than 5. It is true. Then it will calling the method calling statement again. So the value would be 3. Next system.out.println n. It means 4. Then it will checks other condition. So it checks condition until the false. If the condition is false, then it comes out of the loop. So it doesn't lead to the stack overflow exception, right? So it is all about recursion and how the recursion is classified: direct recursion and the indirect recursion. But by doing it so, it leads to the base case stack overflow exception. To overcome the stack overflow exception, the base case condition is introduced. By using the base case condition, we can create the condition to stop that operation. If the condition becomes false, it comes out of the blue. So that's all for the video. Please subscribe Codevthspan YouTube channel. Thank you.